The deeper you dig into the moon, the farther backward through time you travel, because beneath the moon's surface is a frozen record of one of the most violent events in Earth's history. If you stood on the moon with a shovel and tried to dig straight down, the first thing you would notice is how wrong everything feels. No wind, no sound moving through the air, no blue sky above you, only black space, harsh sunlight, and gray surface frozen in silence for billions of years. At first, digging into the moon sounds simple. The surface looks dry, dusty, and lifeless, almost like sand. But the moment you begin digging, the moon starts revealing a strange story. Because beneath that gray dust is an ancient world most people never imagine when they look up at the night sky. A crust scarred by violent impacts. A mantle that still remembers the moon's molten past, and deep below the surface, a hidden core carrying secrets from the earliest days of the solar system itself. So what would really happen if you dug into the moon? The first thing you would dig through is lunar regolith, a loose layer of dust, shattered rock, and tiny fragments of glass created by billions of years of impacts. From far away, the moon looks soft and powdery, but lunar dust is one of the most dangerous materials astronauts have ever encountered. On Earth, wind and water slowly smooth sharp edges over time, but the moon has no weather. No rain, no rivers, no atmosphere. Instead, its surface is constantly bombarded by micrometeorites, traveling at enormous speeds. For billions of years, those impacts crushed rock into razor-sharp particles. The dust clings to equipment, scratches surfaces, damages machinery, and if inhaled inside a habitat, it could become extremely dangerous to human lungs before you ever reach solid rock. The moon would already be fighting back, and digging itself would feel completely unnatural. The moon is only 1/6 of Earth's gravity. That means your body would feel lighter. You could lift heavy material more easily, but every movement would feel awkward. On Earth, your weight helps force a shovel into the ground. On the moon, pushing downward would push your body upward instead. Even simple tasks become difficult in low gravity. And then there is the environment itself. No breathable atmosphere, no protection from radiation, no natural temperature control. In direct sunlight, the surface becomes dangerously hot. Inside shadowed craters, temperatures plunge into extreme cold. A simple digging project would require pressurized suits, life support systems, radiation shielding, advanced drills, and machines designed to survive abrasive dust that behaves almost like powdered glass. Even a small hole on the moon would become an engineering challenge. A deep tunnel would become something far more dangerous. But beneath the dust lies something even more fascinating. The lunar crust, a rocky shell shaped by ancient collisions, volcanic eruptions, cooling, cracking, and billions of years of bombardment. Every layer tells part of the moon's history. Some rocks formed from ancient lava flows. Others were blasted outward during massive impacts powerful enough to reshape entire regions of the surface. The deeper you travel, the farther backward through time you go. And unlike Earth, the moon preserves its history almost perfectly. Earth constantly erases its past. Wind reshapes landscapes. Rain erodes mountains. Plate tectonics recycles crust back into the planet. Life itself transforms the surface continually. But the moon is different. It has no oceans, no weather, no forests, no tectonic recycling. Ancient scars remain visible for billions of years. Digging into the moon would be like opening a frozen archive from the early solar system. And the deeper you went, the stranger the story would become. Because the moon was not always cold and silent. Billions of years ago, it may have been covered by a global ocean of magma. Many scientists believe the moon formed after a catastrophic collision between the early Earth and another massive object roughly the size of Mars. The impact was so violent that enormous amounts of molten debris were blasted into space. Over time, that debris gathered together and formed the moon. In the beginning, the young moon may have glowed with heat, a partially molten world slowly cooling in darkness. Heavy materials sank inward. Lighter rocks floated upward and formed the crust. That means digging into the moon would not just reveal lunar history, it could reveal the origin story of Earth itself. The moon may be a surviving memory of the collision that helped shape our planet. That is what makes the idea so powerful. You would not simply be searching for rock. You'd be digging into the aftermath of one of the most violent events in planetary history. And if humans could somehow dig deep enough, they might eventually reach the lunar mantle. The mantle is the thickest layer inside the moon, mostly solid but still carrying heat from the past. Studying it directly would become one of the greatest scientific breakthroughs in human history. It could reveal how the moon cooled, how its volcanic systems once functioned, and why the near side and far side of the moon look so dramatically different. The near side contains enormous dark plains formed by ancient lava flows. The far side is rougher, brighter, and heavily cratered. Some scientists believe differences deep inside the moon help create this imbalance, and digging into the mantle could finally help explain it. But even deeper below the mantle lies something even more mysterious, the hidden core. Small compared to Earth's core, but still incredibly important. Data collected from Apollo-era moonquakes suggests the moon contains multiple internal layers, including a core that may have both solid and partially molten regions. This is where the moon becomes truly unsettling. From the outside, it looks completely dead. No atmosphere, no oceans, no life, no visible movement. But deep inside, it still carries heat, structure, and evidence of a violent beginning. The moon is not just a lifeless rock floating through space. It is a world that evolved, a world that cooled, a world that changed, and somehow it preserved the evidence. If humans ever managed to dig deep into the moon, the discoveries could completely change our understanding of the solar system. We might uncover ancient volcanic layers untouched for billions of years, hidden lava tubes large enough to shelter future lunar cities, frozen pockets of water ice trapped inside permanently shadowed craters, buried gases, rare minerals, or rocks older than almost anything preserved on Earth. And perhaps the greatest discovery would not be a resource at all. It would be time itself, because the moon preserves history more quietly than Earth ever could. A canyon on Earth eventually erodes away. An ocean floor disappears beneath tectonic plates. Mountains collapse, but on the moon, ancient impacts remain visible for unimaginable stretches of time. The surface becomes a memory, and digging into it would be like opening a record from the birth of the solar system. That may be why the moon feels strangely emotional to human beings. It hangs above Earth every night, silent, familiar, almost comforting. But beneath that pale surface is a world shaped by fire, collisions and darkness, a world carrying evidence from a time before human beings existed, before life walked on land, before Earth itself fully became the planet we recognize today. And maybe one day, future explorers will dig deeper than anyone has ever before, far below the dust, far below the shattered crust, into the hidden layers of a world that has been silently orbiting beside us for billions of years. And when they finally uncover what lies deep inside the moon, they may not just discover the moon's past, they may uncover a missing chapter of humanity's own beginning.